Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep, and warm welcome to the Atomic series for BARC and HAL aspirants. Join the session quickly and mark your presence. I am waiting for you all to join the session. Today we will be practicing the most important questions or model questions or expected questions for this BARC and HAL from the subject algorithms. And today majorly we will be focusing on asymptotic notations and time complexities topic. Okay, those who have joined the session, please mark your presence. Let me know who have joined the session. Also, keep liking and keep sharing the session, all dear friends. So before I start, let me introduce myself quickly. I am Satya, research scholar in CSE with 14 plus years of teaching experience. I have mentored more than 30,000 students all over India in GATE and PSU segment. I am qualified in GATE, UGC NET, SET, and also certified by Cisco into networking and programming. Okay. So guys, this atomic series we have planned with the majority of the subjects, most important subjects, as you see already: compiler design, programming data structures, operating systems, DBMS, discrete maths, COA. Already these subjects questions practice is over, and we will be practicing algorithms and computer networks. Anshul sir will be making you practice digital logic design. So as of now, this is what we have planned for you. So definitely based on your response, we will come forward to plan more and more useful sessions. So you need to just keep attending all the sessions without fail. Okay. Tushar, good evening Tushar. So those who have joined the session, please confirm, am I visible and audible to you clearly or not? Also, please confirm, is it good to go? Shall we start? Okay. All right. Let me present the first question of today's session. Before that, I am expecting all of your confirmation, acceptance to go ahead. And this is my Telegram group through which you can connect with me and with your peer students for either doubt solving or you have any career guidance related queries, or for the PDFs of the session. Okay. All right. So here is the first question, guys. Consider the following functions from positive integers to real numbers. The correct arrangement of the above functions in increasing order of asymptotic complexity. So what would be your answer for this question? If these are the functions we have, we need to arrange these in the increasing order of asymptotic complexity. Come on, guys. Sandeep Sarkar says option B. Okay. Srishti, option B. Right. See, we have basically 5 functions here. Among these, constant is generally less. We take constant time as the less time in the complexity. But if that constant is divided by n, that will be even less. So the smallest function we can say is 100 by n, then constant 10, then in log n square root of n, which is a small we can take, just take some value like n is equal to, let us suppose, okay, just suppose n is equal to like let's say some 1024 kind. If you take n as 1024, square root of 1024 you say, and log 1024 base 2 you take. So obviously we will understand log will be smaller compared with square root. So log n base 2, then square root of n, then n. Okay, so you are all correct. Option B is the right answer. Next question. Let f of n equals to n. Of course, these are previous gate questions, but as I already told you, previous gate questions are definitely possible in the BARC exam. That is the reason why I am making you practice previous gate questions, because same question can come in the BARC exam. Okay. So let f of n equals to n and g of n is equal to n to the power 1 plus sin n, where n is a positive integer. Which of the following statements is or correct? F of n equals to big O of g of n. F of n equals to big omega of g of n. So what is your answer for the second question, guys? AB de Villiers says option A. Okay. First of all, recall the asymptotic notation once. If you need to write f of n equals to big O of g of n, then what is the condition? F of n should be less than or equal to some constant c into g of n. Similarly, if f of n is greater than or equal to some constant c into g of n, then you can write f of n is in the order of g of n, omega of g of n. Right? So now let's take f of n, which is n, g of n, that is n to the power 1 plus sin n. Now you take what is the minimum value for sine? Minimum value of sine theta minus 1, maximum value of sine theta plus 1, isn't it? So if you take when sin n is equal to minus 1, then g of n will be what? N to the power 1 plus minus 1, that is n to the power 0, that is 1. So sin n is equal to 1 and f of n is n. So can you say n is less than or equal to some constant into 1? Is it true? No, it is false. Similarly, if you take sin n value as 1, then what would be g of n? N to the power 1 plus 1, that is n square. So if g of n is equal to n square, can you say n is greater than or equal to constant c into n square? No, right? It is not true for all. Hence, this is also false. So you can neither write f of n less than or equal to c into g of n for all n greater than or equal to n naught, nor f of n is greater than or equal to c into g of n for some n value. Hence, it is neither one nor two. Okay, so the answer would be neither one nor two. Both are false because we want the correct statement. Both the statements are false. Okay, next question. Arrange these functions in the increasing order of asymptotic complexity. F1 we have 2 to the power n, F2 n to the power 3 by 2, F3 n log n, F4 n to the power log n. Quick, I want response from everyone. De Villiers, Srishti, Sandeep and all, please give your answer for the third question. Which is small in this? Definitely n log n will be small. Guys, in these kind of problems, simply take some bigger n value, like n you take as some 65,536, let's say. So n log n would be like 65,536 in 65,536 multiplied by log 65,536 base 2. That would be 65,536 multiplied by log 2 raised to 16 base 2. So this is 65,536 multiplied by 16. I can say this is 2 power 16 into 2 power 4. So this is somewhere 2 raised to 20. And if you substitute the same in n to the power log n, this would be what? 65,536 to the power log n. Log 65,536 is 16. So this is 2 raised to 16 whole power 16. So this is 2 power 256. Similarly, 2 raised to 65,536, which is 2 power n equals to, that is 2 power 2 to the power 16. right? And okay, let it be 2 raised to 65,536 only. This that would be easy for comparison. And we have n to the power 3 by 2, that is 65,536. I am writing as 2 power 16 whole power 3 by 2. So this would be somewhere around 2 raised to 24. So now you give the complexity order. F3, F3 is n log n will be small than F3. I am putting here, this is F3 and this is F4, this is F1 and this is F2. So in this, if you take 2 raised to 20 is small, then F2 is small, then F4 is small, and F1 will be large. So F3, F2, F4, F1, that would be the increasing order of complexity. So option A would be correct. Srishti A.B. de Villiers, option A, not option B. Okay. Next question. Consider the following functions. F of n equals to 2 power n, g of n equals to n factorial, h of n equals to n to the power log n. Which of the following statements about the asymptotic behavior of f of n, g of n and h of n is true? In this, which is large, guys? N factorial would be large than 2 power n than n to the power log n. Just as I given, substitute some 65,536 kind number. Though you don't know about anything about these notations, like this you take some bigger value of n, then n to the power log n would be 2 power 16 whole power 16, right? That is 2 power 256 you take, and 2 power 2 to the power 16 and 65,536 factorial. So here n log n is h of n, that is less than f of n, that is less than g of n. When h of n is less than f of n, what you can write? H of n is equal to big O of f of n. Similarly, when h of n is f of n is less than g of n, what you can write? F of n is big O of g of n. And we can also write for h of n and g of n relation. So h of n we can also write as big O of g of n. And reverse also, like when g of n is greater than f of n, we can write g of n is omega of f of n. Similarly, when f of n is greater than h of n, we can also write f of n as omega of h of n. And similarly, between g of n and h of n, we can write the relation g of n as omega of h of n. So now you see which is correct. F of n equal to big O of g of n, right? G of n equals to big O of h of n, wrong. So option A is not correct. Option B, f of n equals to omega of g of n, no. So no need to check this later one. Option C, g of n equals to big O of f of n, no. So no need to check. H of n equals to big O of f of n, correct. G of n equals to omega of f of n? Correct. So option D is the right answer for this question. Okay. Please post if you have any doubts in the comment box. Next question. So guys, you see in the GATE exam itself, these model questions have come multiple times. So definitely you can expect this model question in the BARC exam also from algorithms, BARC or HAL. Okay. Now we have f of n, f1 as 10 to the power n, f2 as n to the power log n, f3 as n to the power square root of n. So now, which would be ascending order of functions? Srishti says A. Okay. Same. If I take some n value as 2 power 16, f1 would be 10 to the power 2 to the power 16. You can say this is something like 100 whole to the power 16. Thank you, Naveen. f2 n to the power log n. So this would be 2 power 16 whole power 16. This is somewhere 2 power 256, and f3 2 raised to 16 whole to the power square root of 65,536, 2 power 16. This is 2 power 8. That is 256. So which will be bigger? Option definitely f3 would be bigger, no doubt. But in f1 and f2, which will be bigger? 100 to the power 16 would be bigger, or 2 to the power 256 would be bigger. Okay, I'll write in more simple way. 65,536 whole to the power 16 would be bigger, or 100 to the power 16 would be bigger. Obviously 65,536 will be bigger. Hence definitely f1 is less than, f2 is less than f3. Right. Next question. The time complexity of the recurrence relation T of n equals to 4T of n by 2 plus n square by log n is. Come on, guys. What would be your answer for this question? This is a very simple master theorem based question, guys. So I always suggest students to learn master theorem, because while solving the recurrence relation, if you know master theorem, much time can be saved. And in BARC kind of exam, most probably master theorem based recurrence relation will be given, not the one which you have to solve using substitution method, because it takes time. We know BARC has 100 questions with 120 minutes, so definitely formula based questions would be more preferable. Hence, if there is a recurrence relation question in the BARC, most probably like 95% I can say a master theorem based recurrence relation only will be given. So let us see master theorem first. So we have master theorem for a function where the input size is decreasing exponentially, decreasing linearly. So we have two forms. Now if you see the given recurrence relation, this is decreasing the input size, which is n value, is decreasing exponentially. So if I compare 4t of n divided by 2 plus n square divided by log n with a into t of n by b plus n to the power log to the power p n. Let me write this like this, log to the power minus 1 n, because 1 by log n is log to the power minus 1 n. So if I compare, a value is 4, b value is 2, k value is 2, p value is minus 1. This is what you have to extract. So now what you have to do, you should compare a and b power k. A is 4, b to the power k is 2 square also 4. So a equal to b power k relation holds good here. So you see, when a equal to b power k, examine p value. What is p now? Minus 1. So when p is minus 1, what is the time complexity? N to the power log a base b log n, right? So this would be n to the power log 4 base 2 log n, that is n square log n. So option C would be right answer. Okay. Next question. The recurrence relation and time complexity for selection sort under average case. Recurrence relation and time complexity. Okay, guys, whoever are watching, give your response. Try to make the session interactive. Also, please do share this session to your friends, so that your friends also will know about this session happening. It's a direct question. What is the recurrence relation for selection sort in average case, and what is the time complexity? We know the time complexity is big O of n square in all the cases, and the recurrence relation is t of n minus 1 plus n. because how we perform selection sort, recall once. One element we will place in the right position by finding the small. So to find the smallest element in all n elements, we do n comparisons. Okay, let's say n minus 1 comparisons, asymptotically it is n. And we repeat the procedure on remaining n minus 1 elements. So recursively we are doing the procedure on n minus 1 elements every time. So that is t of n minus 1, and every time you spend time n, I mean to find the smallest element. So that is option. Okay, no Srishti. So guys, the intention is you have to learn the time complexities, recurrence relations of all the data structures, all the sorting algorithms, all the algorithm applications without fail, because you can expect definitely a question, direct question on these time complexities. Okay, next question. Assume that a merge sort algorithm in the worst case takes 30 seconds for an input of size 64. Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? What is worst case time complexity of merge sort? N log n. So here, if n is equal to 64, it is given the time equals to 30 seconds. If n is equal to 6 minutes, no, what is n we have to find out, so that the time should be 6 minutes, that is 360 seconds, I say. So n log n should be 360. For what n? This will be true, like in that way you calculate. Okay, give your answer, guys. I am waiting, I am expecting responses from everybody, please. So in the maths, when we get these kind of things, we will apply some constant. Some constant c into n log n is, we are given with 30 seconds already. So some constant c into, for what n, that is 64, log 64 is 30 seconds. So some constant c equal to 64 into 6, 30. So what would be c here? 30 by 64 into 6. Let's say this would be 5 divided by 64. So the same constant c into n log n should be 360 for what n? So 5 by 64 into n log n should be 360. So for what n log n equal to 360 into 64 into divided by 5. Let's say it is 5 sevens are 35. 72 into 64. So can I write this also as some, what is 72 into 64? Okay, let me put it in this way. 72 into 64, I am dividing 72 as 9 into 8 into 64. Okay, 64 into 8 is what? 512. So I am putting it in this way. It is 512 into log 512 into 9. So if n is 512, log n would be what? Log 2 power 9 512. So log 512 would be 9. Hence what would be n? 512. Okay. Next, which algorithms take same time in all cases? Which algorithm take same time in all cases? We know quicksort, in the best case and average case it will take n log n time. And worst case n square, right? Merge sort will take n log n in all the cases. Bubble sort takes 1 in best case, n square in average, and what worst, these worst cases. So merge sort is taking same time in all the cases. So like this, a simple question can be asked, just like this. So what can be the answer? Do you know or not? Okay. Insertion also takes n in best case, n square in average and worst cases. Just like bubble sort. Bubble sort not one n. Okay. But selection sort will take n square in all the cases. Merge sort will take n log n in all the cases. So which takes the same time complexity in all the cases? Merge sort, selection sort. Hence, option C would be the right answer. Okay. Last question of the day. The worst case time complexity for inserting an element into a BST is. Good evening, Anu. Into a BST, if you want to insert an element. What is the worst case time complexity? Worst case. So I'll take a skewed BST, guys. Skewed tree as BSTC. Something like 90, 80, 70, 60. Left skewed I am taking. You may consider right skewed also, no problem. So suppose I am taking 6 elements here. If I wanted to insert 30 now, how do I insert? First I compare 30 with 90. 30 is less than 90. Then I compare with 80. Then I compare with 70 and so on. Right? So how many comparisons I am doing? If there are n elements, we are doing n comparisons. So in the worst case, what would be the time complexity? Definitely it is big O of n only. Undoubtedly big O of n only. Okay. Hi Sujan. So guys, this is what for today. I hope what kind of questions can come from recurrence relations or time complexities or asymptotic notations, you got a better idea with this session. There will be one more session on algorithms which covers algorithm design techniques, greedy method, DP, dynamic programming, divide and conquer related. Okay, so keep attending the sessions regularly, keep revising the things. Definitely you will be able to crack BARC exam with your efforts. Thank you. All the very best, guys. See you in the next session. Again, before you leave, don't forget to like the session, share it as much as possible. Okay. See you in the next session. Till then, have a great time. Take care. Bye bye. Thank you, guys. De Villiers, one more series. We'll see based on the students' response. So share as much as possible. Let many students join the sessions. So definitely we will also get some motivation to conduct more and more classes, more and more series for you, right? Thank you.